All right, lesson 5-3, solving radical equations. Here's kind of an overview. So if we're supposed to solve for x in this problem, like normal, we get everything to one side if we can. In this case, that would mean add this 1 to the other side, which adding 1 to the 3 would make a 4, and then square both sides to get rid of the square root. And lastly, subtract the 1 over. So if we had that, something doesn't feel like it worked to me when I'm looking at the problem, because a 15 plus 5 is 20. And 20 square rooted is not a number, so that would be a 4. So I must have copied something down wrong. I see it. Good thing I checked my work when I was done to see if it made sense. That 1 wasn't a 1 at all. It was a 5. So when I subtract that 5 to the other side, this should have been 11. Check that. 11 plus 5 is 16. Square rooted is 4 minus 1 is 3. So there you have it. Check your work. You might almost think I would do that on purpose to emphasize that, but I didn't. Okay. A cube root now, from what we learned on the last lessons and practiced with our different types of roots, but the overall process is similar. So subtract the 2 over. From the 4, we'd have a 2. And then just like we do a square to undo a square root, here we would do a cube to undo that cube root. And don't forget, 2 times 2 times 2 is 8, not 6. If somebody wanted to do this with the rational exponents that we had, remember 1/3 power is the cube root. Raise both sides to the 3rd power. Exponent properties. When you multiply those as 1, get the same answer. Let's see what's next. So this one's talking about like if you had a story problem to solve. And some of my words are cut off on the page here, so. See if we can shrink that down to get it to fit. But you see the equation of the cable on the bridge there. And y is the height of the cable above the bridge. The bridge is down below here. And x is usually how far you are from the middle of the bridge. So the distance up here wanted a select all feature here. So I could shrink that. Bring it back where we can see what it says. Okay. All right, so then they ask, when are we 200 feet from the center of the bridge? So that's the 200 feet from the center, that's x. So x is 200. And we would just put that 200 where the x is, which in this case is our answer. Normally, x is what's in the formula. So you've got a 200 in there. And to solve that for y in this case, multiply by the 0.010583 to both sides. So we got to take this times that. And then we're going to undo the square root with the square. So whatever that answer comes out to, we need to square that. And lastly, after that's gone, we need to add that 220 to the other side. So it's just showing you an example of a problem where you're applying it. But all of this would just be calculator work there. So I'll trust you can operate a calculator by now. Undoing square roots and cube roots. Now this next one, if you notice, I've got a comment on there about making sure you watch out for what's called an extraneous solution. So an extraneous solution is something that gives you an answer, but it's not really an answer. So when you solve the problem, it seems like that's what it would come out to, but when you actually check it, it does not work. So we'll have to watch out for that. So in this problem, start out by squaring both sides. Now, some people will mess this up because you got to do x minus 4 times x minus 4. And they'll leave out that middle term, remember, because you got to go x times x is your x squared. Your negative 4x and your negative 4x makes a negative 8x. And last, your negative 4 times negative 4 is 16. So for the right side here, you've got x squared minus 8x plus 16. And on the left, the squared takes the square root off. And then moving everything over. So my x squared doesn't change. I subtract 3x from 8x, giving me a negative 11x. And add 2, and I've got an 18. And on first thought, that looks nice because 9 times 2 is 18 and adds up to that. So x minus 9 and x minus 2. If you factor, I believe that's how that's going to work out. Now you have two things multiplied. If you think of this one as like a and this one like b, and they equal 0, either the a is 0, which x minus 9, or the x minus 2 is 0, and that's the only two ways to have those two multiplied to be 0 if one of them is 0. Add the 9 over, add the 2 over. Now, a lot of times on these square root problems, when you have those, if you get two solutions, many times, only one will work. So let's double check that. 3 times 2, I'm going to check the 2 first. 6 minus 2 would be 4. Square rooted is 2. And over here, 2 minus 4 is negative 2. So that would not seem to work out. Check the 9. 27. 3 times 9 is 27. Minus 2 is 25. Square rooted is 5. Write that down before I forget it. And 9 minus 4 is 5. So this one does work. But this one that didn't actually work, that's what's called an extraneous solution. Got this reminder on this one as well to make sure when we're done that we do check the answer, because again, as we saw in the last one, sometimes the algebra in the problem will give you a solution that in reality doesn't work. So when we get there, we'll double check that. So the 5/2 power, let's try to get that into a power of 1. So remember, powers to powers multiply. And so 5/2 times its reciprocal, 2/5, would equal 1. So powers to powers multiply. So I'm raising both sides to the 2/5 because 5 times 2 is 10, 2 times 5 is 10. That would just leave me with the x squared plus 5x plus 5 to the first. Don't need to write that. And then 1 to any power, no matter what, because the square root of 1 is 1 and 1 squared is still 1. So this is still just going to be a 1. Let's see, then let's bring that 1 over to this side, make it equal 0. That would be like we subtracted 1 over, so that's a plus 4. Well, that's kind of nice because I think this is x plus 1 times x plus 4 to equal 0. Setting your factors equal to 0 and undoing your operations. So that one would give us x equals -1. When we subtract the 1 to both sides and subtract 4 on both sides, x equals -4. So one of those two solutions. But remember, on these, especially with the weird exponents, and the squared on the denominator right there does mean a square root. So you usually need to check those. And to check it, I'm kind of thinking of a calculator. We could try to do this in our head here, but -1 squared would be 1. 5 times -1 would be -5. And then plus this 5, so that would equal 1. So this first -1 does work. Then let's check the -4. -4 squared is -4 squared is 16. -4 times -5 would be -20. And then plus 5. So that'd be like 21 minus, and so that would be 1. And 1 to the 5/2 power, that equals 1 as well. So that does also seem to work. So in this problem, both of those seem to give me valid answers. Let's see. How about we've got a cubed on one side and a 3/2 power on the other side on this one. And so what are we going to have to do? To solve there. Seems like if you could raise them to a certain power on each side of the problem, that then you would, that would get rid of both exponents. So what I'm kind of thinking of there is if I raise this one to the 2/3, that's going to get rid of the 3/2. If I raise this one to the 2/3, that's going to make it worse because it's like, oh no, that would work too because that'd be 6/3. So let's just do that. If we raise them both, so these two here are going to be like 6/6, or if you do that cross-canceling business, stuff like that, you could think of it like that as well. And then over here, so then this one is just x plus 18 because those are going to be to the first power. And on this side, we're going to end up with the x minus 2 to the second. This 2 remains over a 1 for second. And then when you FOIL this out, like x minus 2 times x minus 2, take the first two multiplied, Take the outside and the inside, that's 2x, negative 2x and negative 2x for a negative 4x. And then the last two for a plus 4. Now move everything to one side. When I subtract that x over, that's going to make a negative 5x, right? And when I subtract the 18 over, negative 14. And 14 is 2 times 7. That can make a 5, so it seems like this is probably going to factor. Bigger number, a negative. Smaller number of positives, so the negative 7x, positive 2x combines to make a negative 5x. Set your factors equal to 0, the zero product property. And then do your operations. Add 7 and subtract 2. And then again, check in the original problem, because a lot of times with these weird exponents, something won't work. So if you go 7 plus, checking the 7 first, 7 plus 18 would be 25 to the 3/2 power. Remember how we talked about that before that? It could be like 25 to the 1/2 power first, then to the third. 1/2 power, remember that's a square root of 25. 2 in there in the index. If you don't write anything is implied. So that's 5 to the third, and then 5 times 5 times 5 is 125. 25 times 5, or 5/4, $1.25. And then on the other side, when you put in the 7, 7 minus 2 is 5 to that third power, so that's the same thing. So that one did work, checked out on both. So that was when I put in the 7. And then what about the negative 2? Negative 2 plus 18 would be negative 2 right down here. Plus 18 would be 16. And that same thing, 3/2. Remember the 1/2. It's like 16 to the 1/2 and then to the third. So this is a square root of 16, 4 to the third, which I happen to remember is 64. Then let's check the negative 2 over here. Negative 2 minus 2 would be negative 4 to the third. That'd be negative 64. Negative 64 is not the same as positive 64. So the negative 2 there would end up being an extraneous solution. So it's not included, just the 7 in this case. All right, these now, when you have more than one square root in the problem, it just makes for an extra step before you're going to have the problem solved. So in these problems, we're going to end up having to square both sides of the equation twice before we finally get rid of before you get rid of both square roots. So first one, we can square both sides and FOIL it out on the left. It's kind of messy. Just be patient, careful, and check your work. If you want to, when you're doing this, you could even make a rectangle to organize it. By that, what I mean is I'm going to put this square root of x plus 9 and minus 2 square root of 2x, and then over here, square root of x plus 9 and the minus square root of 2x. And so when you are squaring that, right now I'm taking this times itself. Square root of x plus 9, square root of x plus 9 is just x plus 9. This one is where it's gross, so a negative here would be negative, and then 2x times that would be 2x squared, and then 2x times 9 would be 18. And then down here, I've got the exact same thing. So if I did that carefully, this square root of x plus 9 negative 2x is the same as this square root of x plus 9 negative 2x multiplied. And then a negative times a negative here would be positive. Square root of 2x square root of 2x would just be a 2x. And then on the right side over there, that's going to be a 9 over there now. So combining everything in here, I've got x plus 9 and 2x. That would be x plus 2x is 3x plus that 9. And then I've got minus 2 of these things. They are kind of gross. 2x squared plus 18. And your next step is get your square root all alone. So I'm going to subtract that to the other side. And I'm going to subtract that to the other side, which would leave me the negative 2 square root of 2x squared plus 18 from right here. The negative 9 subtracted there would cancel. I just have this negative 3x over there then. The next thing I was kind of thinking of is we could divide by this negative 2 to move it to the other side. But then that's going to give us a fraction. So somebody else might choose not to do that step. But I'll go ahead and do that. If you didn't do it and you squared both sides in your next step to get rid of this square root, then we would have to square this number out here. So let's go ahead and square both sides now. So now when I do that, this removes that square root. Square the 3 halves. 3 halves times 3 halves. 9/4. And then this x squared here. Now that, yuck. I'm kind of thinking now I don't like the 4 in the denominator there. So if I multiplied everything by a 4 right now, both sides of the equation, that would give me 8x squared plus, I think that's 72, equals this 4 times here cancels that, leaving 9x squared. Now subtract 8x squared to the other side. Holy smoly. That's going to leave that 72 on the left. And 9x squared is minus 8x squared is an x squared. And my final answer, almost. Now, let's see. 72 is 36 times 2. Square root of 36 is a 6, which would give me 2 answers like that. And then having to go back and plug those in to check them seems kind of gross because I got to put a square into this square root. So I am going to check this by using a little bit of an unconventional method. We've done this before, but I'm going to hop on over to Desmos to just see if my answers do come out somewhat with that 6 square root of 2 and see if there's 2 answers. First of all, a 6 square root of 2, just putting it in a calculator, is about 8.485. 8.485 approximately. So I've got a plus or minus on that. And then let's just see what happens when we use it in Desmos. So my original problem was that square root of x plus 9 minus square root of 2x equals 3. So when I'm using that, let's see if I don't know if I have a Desmos open right now. Desmos.com, graphing calculator. Let's see, I'll share that screen with you. And I'm going to put in my two equations. Or no, I can put all this. I think I'm going to put it in 2. So y equals squirt SQ RT, and then parentheses if you have to, x plus 9, arrow to the right to get out of the square root, minus, and then the SQRT again, the 2x right there. And then the other side of the equation is 3, so then we're going to go down below, just click in the next line and put y equals 3 and look to see where this intersects. So there really, it looks like there's a single point there. Square root of x plus 9 minus the square root of 2x, and where it equals a 3. Do they actually intersect there is the question then. Because it sort of looks like that point is on both of them. If I put a 0 in here, square root of 9 is 3 minus 0 would be 3, so they do intersect there. But that does not look like the answer that I came up with. So I think there's a mistake someplace. Come back over here and see if I do have that equation written. Square root of x plus 9 minus square root of 2x equals a 3. I squared both sides of my equation. Just kind of looking through all of these parts. This has to be right. This one would be a negative square root. That's kind of, it would be a little suspicious of this one. So I'm just writing it out here to check. Negative square root of 2x times the square root of x plus 9. That'd be in negative times a positive is negative. 2x times x plus 9 is indeed 2x squared plus 18x. There it is. I didn't distribute that x through onto the 9. Should have been an x there, an x there, an x there, an x there, an x still here and here. That's not so bad. Not too much to have to fix there. Fix it down here at the end now. Finish this off down here. So I think it's about right there on over that I probably need to erase. Just to demonstrate that sometimes, let's see, I think it's still okay to divide that negative 2 over. The right side will still be okay there. 9/4 x squared. And multiplying by this 4 is still even okay, giving me 8x squared, 72x equal to the 9x squared. And then subtracting, yeah, let's do it that way. And then we'll move both of these over to make it equal 0 maybe. So I'll have 9x squared minus this 8x squared is just x squared, and then the minus 72x equals 0. Factor out an x. So my two answers for x are 0, and then this one, when you set it equal to 0 and undo your operations, by adding 72 to the other side would be a 72. This one is the one that if you plug it in and check it, I don't think it's going to work. So 72, that's a 72, plus 9 is 81, square rooted is 9. And then 72 here would be 144, square rooted is 12. And 9 minus 12 is negative 3, not 3. So that's the check step to see that that one's incorrect. So that one should not have taken that long if you don't make a mistake, but just to demonstrate, if you persevere, stick with it, check it, you've got lots of tools to help you figure out the correct solution on that problem. All right, and then to try to do like a word problem here, usually on each of those lessons. So the body surface area of a human, where you know the height, h, and the mass or weight in kilograms and the height in centimeters. So the body surface area can be calculated with this formula. And then they go on and they say if somebody does have a body surface area of 1.9 and they're 160 centimeters, well, what was their mass or weight? So seems like this sort of thing could be useful in like forensics or something. So my BSA would go here, 1.9, and then my height in centimeters right there. And we're looking for the mass. And I believe this is an actual formula that is used. So 1.9, and then you can, the radical or square root property says you can split these when it's all either multiplication or division. And so something like that, or sometimes instead of splitting these numbers into two separate, somebody else might split that just as one fraction with the square root of 160 over 3600. And I think I'll just leave it like this. So then I've got my 1.9, the square root of 160, because 160 is 16 times 10, and that 16 square root will get out as a 4. Remember how they like you to simplify those? So this is 4 square root of 10 times the square root of m, all over 60 times 60. 6 times 6, 36, add those two zeros. So that's just a little over 60. Trying to get the m alone. So let's multiply by that 60 to get it to the other side. If you have your own method for shortcuts, but this is what you're doing, by all means, feel free to use those shortcuts. I'm all about that. If you don't practice them when you get to the ACT, SAT problems, and it's all timed, you're going to be slowing yourself down. So 114 on the left, that takes that out of there. And then we're going to really have this over my 4 square root of 10 because I got to divide by that. And then that's going to equal my square root of m. And so to get m alone after all that, we're going to have to square both sides. And so on this problem, we're going to end up 114 squared is like 12,996. And maybe before you even do that, you think about 114 divided by 2 anyway here would be 57 over 2. So you could think about doing that a little bit, reducing that down. So I've got 57 over 2, but I've also got that square root of 10 down there. And just a reminder then, if they don't like the square root in the denominator, we got to get that out of there. But I don't know if I'm going to do that because remember, this equals the square root of m now, and we're going to square both sides, and that should take care of the square root of 10 down there. So then let's square this. I square this now, well, that's going to give me the 57 squared over 2 squared is 4, and the square root of 10 squared is just 10. So 57 squared over 40, 3249 over 40 if you leave it like that, which is 81.225. Seems like a weird answer again. To where I think I'm going to do that same thing we did on the last one. I'm going to jump over to Desmos and type that in. The left side, which would be the y equals 1.9, and the right side, the y equals the square root of 160 times x all over 3600. And so if we, let's see, let me give you that screen. Let's take out this and put in a big square root. And in the numerator had 160x all divided by slash 3600. And we were wondering when it actually equals 1.9. So it's not 31.9, 1.9. So I don't see my red graph. Oh, it's gonna be way out here. Didn't we had it like 80 something or something like that. That's looking like that might actually, seems pretty reasonable. So out here, if we find where that is, someplace in here, 81.225, which is what we did get. All right, well, so on that one, we actually did get the correct answer. That's nice. Let's see. Yeah, 81.225, there it is. And that's the last example in that lesson, but solving equations with square roots.